Works Minister Dato Sri Alexander Natsalingi said his ministry, however, is always prepared and closely monitoring.
At 1:57 in the morning, the ground beneath one of Southeast Asia's most populated islands lurched sideways. 78 million people across 5 countries felt it, and yet 0 lives were lost, 0 injuries, 0 structures collapsed. Here is what made scientists stop in their tracks. The source of this earthquake came from a piece of ocean that vanished 16 million years ago. Over 160 buildings in this region have already been identified as at risk of partial collapse, and most of them were built before this country had any seismic standard at all be. Navakanish, a researcher at the Southeast Asia Disaster Prevention Research Initiative, University Kebangsaan, Malaysia, told Bernama the slab accumulated stress until it failed and released massive energy. Today we find out exactly what that meant and what it means for the millions of people living above it. Sabah is the eastern Malaysian state on the island of Borneo, one of the largest islands on Earth, a place of extraordinary natural beauty, a growing tourism economy, and home to millions of people who had no idea what was about to happen beneath them. On February 23, 2026, at precisely 12:57 in the morning local time, a magnitude 7.1 earthquake ruptured at a depth of 6019, 8 kilometers below the surface. It was confirmed almost simultaneously by the United States Geological Survey, Indonesia's seismic agency, Germany's GFZ Research Center, and Australia's Seismological Services. There was no disagreement about what had just occurred. This was the most powerful earthquake to strike this region in over 103 years. And here is the paradox that set the scientific community talking for days after an earthquake this powerful in a region this populated should have been catastrophic. Instead, nothing collapsed. No one was seriously hurt by mid-morning. The fish markets of Kota Kinabalu were open for business. This video will answer 3 questions. What actually happened that night? What is the science behind an earthquake this deep and this strange? And what is the real risk that is not making the headlines? This event did not just shake one city. It was felt across Singapore, Brunei, the Philippines, Thailand, and Cambodia. And the story of how it reached that far is where the real science begins. Picture this. It is just before 1 in the morning on a Monday. Most of Kota Kinabalu, the coastal capital of Sabah, is asleep, and then the ground moves. The German Research Center for Geosciences filed its first report within 5 minutes of the rupture, magnitude 7.1. Indonesia's seismic agency confirmed almost immediately, then Australia, then the USGS, 4 independent centers, 4 confirmations in under 10 minutes. On the ground, the experience was immediate and disorienting. A resident of a high-rise in Kota Kinabalu later told the Malaysian National News Agency, Bernama, that the shaking lasted about 10 seconds, but felt far longer. The ceiling fan in his living room swung violently. Picture frames rattled off walls. He woke his wife and 3 children and rushed them barefoot down the emergency stairwell to the parking structure below. On the 6th floor of another building, a clinic assistant named Clarice Eve Moji Go had just come off a night shift. Her wardrobe door swung open on its own. The window shook in its frame. She grabbed her mother, a flashlight, and her phone and ran out on the resort islands of Manukan, Sapi, and Gaya, popular with divers and day visitors. Guests reported beds shifting and wooden structures creaking in the dark. Power stayed on across the region, but beachfront operators moved guests away from the waterline as a precaution until authorities could formally rule out a tsunami. In the waterfront hotel district of Kota Kinabalu, some tourists stood barefoot in open-air car parks for nearly an hour before management gave the all clear, and then the shaking crossed borders. In Singapore, 1,500 kilometers to the southwest, residents in eastern neighborhoods were posting to social media within minutes. One person near Katong Park described their apartment shaking quite significantly. Another reported hearing what sounded like a loud bang at their front door. Felt reports streamed in from Brunei, from the Philippines, from Phuket in Thailand, from Phnom Penh in Cambodia. The European Mediterranean Seismological Center eventually collected 5 individual felt reports from 5 separate countries. The official response moved quickly. Deputy Prime Minister Ahmad Zahid Hamidi chaired the National Disaster Management Committee within the hour. Coastal patrols were deployed to the districts of Putadan and Kota Kinabalu. The Sabah Fire and Rescue Department confirmed all stations were actively monitoring and patrolling their areas. Met Malaysia Director General Mohd Hisham Mohd Anip confirmed that no aftershocks had been recorded and explained that the extreme depth of the epicenter meant only mild tremors reached the surface. By mid-morning, the fish vendors of Kota Kinabalu's central market were back at their stalls, merchandise restacked, hanging scales rehung. The city was functioning. 0 fatalities, 0 injuries, 0 structural collapses. But the conversations at those market stalls kept circling back to the same question: could it happen again? Could it be worse? So the real question every seismologist was now asking was this: why did an earthquake this powerful produce so little impact on the surface? And the answer leads us somewhere no one expected, 620 kilometers straight down. Here is where the story becomes something no headline can fully carry. To understand why a 7.1 magnitude earthquake left no structural damage, you need to understand something called a deep focus earthquake. Any rupture occurring below 300 kilometers beneath the surface falls into this category. At those depths, the enormous volume of mantle and crust between the source and the surface acts like a giant absorber, dissipating the energy before it can reach the ground with full intensity. The source of this earthquake was farther from the nearest human being than the distance from London to Paris. Twice over. That explains the mild shaking. But it does not explain what scientists found when they traced the rupture back to its origin point. And this is the part that genuinely rewrites the textbooks. Seismologists Kyle Bradley and Judith Hubbard, writing for Earthquake Insights, traced the rupture to a slab of subducted rock that does not appear in USGS Slab 20, the most comprehensive map of the Earth's tectonic structure ever assembled. Think about that for a moment. This earthquake did not originate on any known fault line. It did not rupture along the edge of any mapped tectonic plate. It came from a piece of the planet that, according to our best existing models, should not have been there at all. Their analysis points to a source that sounds like something out of science fiction. The remnants of what scientists call the Proto-South China Sea, a theoretical ancient ocean basin that once separated the island of Borneo from mainland Asia, were gradually absorbed into the Earth's mantle roughly 16 million years ago. A vanished ocean, still releasing energy, deep beneath a modern city. B. Navakanesh, researcher at the Southeast Asia Disaster Prevention Research Initiative. University Kebangsaan, Malaysia, explained to Bernama the earthquake resulted from deep slab deformation. Under high pressure at such depth, the slab accumulated stress until it failed and released massive energy. Most of that energy was absorbed by the mantle and crust before reaching the surface. And then came the detail that truly stunned researchers. At a depth of 620 kilometers, rock does not fracture in the way we typically understand. The temperatures are simply too extreme for traditional brittle rupture. The leading hypothesis is a process called transformational faulting. The mineral olivine, the dominant mineral in the upper mantle, undergoes a sudden change in its crystal structure. Under extreme pressure, rearranging its atoms into denser configurations. These phase transitions can cascade through the surrounding material and trigger an earthquake like rupture Even in rock too hot to shatter in any conventional sense, this earthquake did not break rock. It transformed it. The USGS confirmed that this is the first magnitude 7.0 or larger earthquake to occur within 250 kilometers of this epicenter since 1950. In over 70 years of recorded data, only 2 events of MM6 or larger had been recorded anywhere near this zone, and both occurred at far shallower depths. So the deep earthquake was, in a sense, the safer kind. But while scientists were still tracing its source, a separate and far more pressing question was forming on the surface, one that has nothing to do with what is 620 kilometers down and everything to do with what is standing right above it. Remember what we discussed earlier, the paradox that a 7.1 earthquake produced no casualties. This is where that paradox stops being reassuring, because the real risk in Sabah has never been what is happening 600 kilometers underground. It is what is happening at the surface. Sabah sits at the convergence of 3 major tectonic structures, the Sunda Plate, the Philippine Sea Plate, and the Indo-Australian Plate, all pressing against each other beneath northern Borneo. The state is laced with shallow, active fault systems. The Crocker Fault runs directly through Kota Kinabalu itself. Maudner Ismail Abdul Rahman, a senior lecturer in marine geoscience at University Malaysia Terengganu, confirmed to Bernama, Sabah remains the most vulnerable area in Malaysia due to its proximity to this subduction zone, not the most vulnerable occasionally, consistently, structurally, and the memory of why that vulnerability matters is not abstract. It has names. It has a monument. On the morning of June 5, 2015, a magnitude 6.0 earthquake struck just 18 kilometers below the surface near the town of Renau. To put that in perspective, that earthquake was 20 times weaker than the one that struck in February 2026, and it was 34 times shallower. The difference in depth changed everything. Boulders the size of cars broke loose from the granite face of Mount Kinabalu and came down the mountain at speed. 29 students and 8 teachers from Tanjong Kawang Primary School in Singapore were on the Via Ferrata climbing route when the mountain moved beneath them. 18 people did not come down from that mountain. 6 of them were children. A government monument in Kundasang still carries all 18 names. In May 2025, just 8 months before the February 2026 earthquake, 2 of the survivors made a journey back. Amir Uzair and Peshdiant Patel, both now 22 years old, returned to Mount Kinabalu and completed the summit for the first time since the event that took their classmates. They were reunited on that mountain with Cornelius San, the guide who saved one of their lives that morning a decade earlier. 8 months after that return, the same region absorbed the most powerful earthquake in its recorded history. The only reason the February 2026 outcome was different from June 2015 is that the rupture began 600 kilometers deeper. That is not a policy, that is not a plan. That is geology giving a region a reprieve it did not earn. And this is the part that is not making the headlines. A government-initiated vulnerability study assessed more than 500 buildings across 7 districts of Sabah. The majority were built during the construction boom of the 1980s, designed to handle gravity loads and wind, not seismic stress. Over 160 structures in the Kota Kinabalu and Kota Balud districts alone were classified as grade 4 vulnerability. That classification means potential partial collapse in a moderate earthquake event, not an extreme one, a moderate one. Malaysia's first seismic building code, the National Annex to Eurocode 8, was not published until late 2017. Every structure built before that date was designed with no seismic standard whatsoever. The population of Sabah has quadrupled since the last major shallow earthquake struck Lahad Datu in 1976. More people, more buildings, the same fault lines, the The 2026 earthquake produced no casualties because the rupture began 600 kilometers deeper than the one that preceded it. But the shallow fault systems above Sabah have not moved yet. So the question is not whether the science is concerning, it is whether the response is ready. This is the part of the story that most channels will not spend time on, because it does not resolve neatly. 3 questions remain open, and they are not small ones. First, if more than 160 buildings in Kota Kinabalu face potential partial collapse in a moderate shallow earthquake, and the region sits above one of the most tectonically complex junctions on the planet, what is the retrofit and preparedness plan? A vulnerability classification is not an intervention. Knowing which buildings are at risk is only useful if that knowledge leads to action. Second, the seismic building code that now exists applies to new construction. There is no national retrofit program currently in place at a scale comparable to those in Japan, New Zealand, or Chile, countries that have faced similar structural exposure and responded with systematic upgrading of their existing building stock. Malaysia's code is 8 years old. Most of the buildings in Sabah are decades older. Third, if the remnant slab of a theoretical vanished ocean, unmapped by the most comprehensive tectonic models ever assembled, can produce a magnitude 7. One event after 16 million years of inactivity, the question that follows is a serious scientific one. What other unmapped slab remnants exist beneath this region? And what do we still not know about the structure of the Earth beneath Southeast Asia? Now, to be fair and clear, the immediate response to the February 2026 earthquake was handled with genuine efficiency. The National Disaster Management Committee was activated within the hour. The Sabah Fire and Rescue Department had all stations deployed and monitoring before dawn. Coastal patrols ruled out a tsunami risk within minutes of the rupture. The institutional machinery worked, but emergency response and long-term preparedness are 2 different conversations. Southeast Asia is not alone in this exposure. The region sits at the meeting point of multiple active plate boundaries, the same geological context that produced the 2004 Indian Ocean event and numerous major Philippine earthquakes. Sabah's situation is not unique. What is notable is the documented gap between its identified risk and its current readiness. The slab beneath Sabah is still there. The shallow faults above it have not moved. And seismologists now know that unmapped remnant structures exist at depth in this region, which means the Earth's internal architecture here is less understood than current response frameworks assume. This is not a story that ends with an all clear. The monitoring continues. But the questions it leaves behind are not small ones, and they are not going away. On the night of February 23, 2026, the most powerful earthquake in 103 years struck the island of Borneo. No one was seriously hurt. The reason? 620 kilometers of mantle and crust, absorbing the energy of a transformation that began when an ocean floor vanished 16 million years ago. That is genuinely extraordinary. It is also, in every meaningful sense, temporary luck. There are 2 timescales at work in this story, and they do not speak to each other easily. Geological time moves in millions of years, gives no warning, and follows no human calendar. Human time has an 8-year-old building code, a vulnerability study with 160 flagged structures, and a monument in Kandasang with 18 names carved into it. The February 2006 earthquake is not a disaster story. It is a diagnostic. The Earth provided a rare, relatively harmless demonstration of what it is capable of in this region. A 7, 1 magnitude rupture that reached the surface as a gentle tremor because the source was deep enough. The next rupture may not be. How Malaysia responds to that diagnostic and how the broader scientific community approaches the unmapped interior of this part of the planet is the story that is still being written. The earthquake is over. The monitoring continues. But the question of what comes next, that one is still open.